Hello students, welcome to EPG Pathshala. I am Vikas Singla from Punjabi University, Patiala. Today, we are going to talk on module Quantitative Methods of Deciding Facility Location from Paper Operations Management. The emphasis of this chapter would be to discuss quantitative ways of identifying factors and evaluating importance of each factor in location decision making. Following four methods have been discussed. Firstly, cost profit volume analysis method, factor rating method, center of gravity method, and lastly, transportation model. Chapter emphasized on importance of location decision as it had long-term financial impact on company's profitability. It was also discussed that a location decision depended on various factors. These factors vary in importance from service to manufacturing industry. A firm can have various selection alternatives, but study of these factors help a location decision maker to decide on the most relevant location. The deciding factors are governed by strategic objective of the firm. A profit-oriented firm would be dictated by different factors as compared to a low-cost producer. Similarly, influencing factors also depends on the nature of the firm. That is, whether it is service-oriented or a manufacturing concerns. These factors were discussed in previous chapter. This chapter would discuss quantitative methods to evaluate these factors. Precisely, the emphasis of this chapter would be to discuss quantitative ways of identifying factors and evaluating importance of each factor in location decision making, taking into consideration objective and nature of the firm. As discussed, following four methods have been discussed in this chapter in detail. Firstly, cost profit volume analysis. Secondly, factor rating method. Thirdly, center of gravity method. And fourthly, transportation model. The first quantitative method of location decision making has been discussed. The method is cost profit volume analysis. A firm could decide on a particular location out of multiple alternatives if that location produces at lowest cost and gives maximum profit. This method provides calculations to achieve any of the above stated objective if a firm fulfills following assumptions. First, fixed costs are constant for a particular range of output at a particular location. Second, variable costs are linear for selected range of output. That is, variable cost does not change if output varies over a particular range. Lastly, all the selected location alternatives produce same and only one item. If objective is to identify a location with least cost of production, then total cost for each location can be computed by using following formula. Total cost is equal to fixed cost plus variable cost multiplied by quantity or volume of output. If objective is to identify location with maximum profit, then total profit can be computed by using the following formula. Profit is equal to quantity or volume of output multiplied by difference of variable cost and revenue. This term is then subtracted from fixed cost. That is, profit P is equal to quantity Q into revenue minus variable cost minus FC, that is fixed cost. This has been illustrated by the following example. Fixed and variable costs for four potential locations, that is A, B, C and D, are given in the table. For instance, fixed cost for
location A is 2,50,000, for location B 1 lakh, for location C 1,50,000, and for location D 2 lakhs. Also, variable cost for each location is given in the table. Variable cost per unit at location A is rupees 11, at location B is rupees 30, and so on and so forth. If expected output at selected location is estimated to be 10,000 units, then which location would provide the lowest cost? This has been calculated by using formula in equation 1, where total cost for location A would be 2,50,000 plus 11 into 10,000, which would be 3,60,000. Similarly, by using the same formula, total cost for locations B, C, and D has been calculated. Total cost for B is 4 lakhs, total cost for C is 3,50,000, and the same formula gives total cost for D as 5,50,000. From the calculations, it can easily be interpreted that location C should be selected for manufacturing the same product, as this location would incur minimum cost out of given alternatives. This slide indicates another illustration of cost-profit volume method. Following data shows fixed and variable cost for a particular product which can be manufactured at two alternative locations, that is A and B. The demand for this product was estimated to be constant at 8,800 units annually. Also, it was assumed that per unit of the product sells at rupees 6. It needs to be determined that which location would yield highest profit. The table data indicates fixed cost of rupees 8,000 for location A and rupees 9,400 for location B. Variable cost for location A is given to be 44,000 and for location B as 35,200. From the data given, revenue from selling of each unit is rupees 6 per unit. Annual demand is constant at 8,800 units. So total revenue for location A would be 6 into 8,800, that is 52,800. And revenue for location B would be 6 into 8,800, that is 52,800. By using formula in equation 2 discussed in previous slide, profit for each location would be: profit for A is rupees 800, and the same formula when applied to location B, the profit for location B would be rupees 8,200. As the profit from location B is much higher than profit A, hence location B should be selected as it gives more profit than location A. Another important method for location decision making is factor rating method. Factor rating method of location analysis is perhaps the most widely used method of evaluating alternative locations for a firm. This method is a combination of both qualitative and quantitative methods for identifying the most feasible location. The method involves following steps. Step 1. Firstly, by applying qualitative method, which involves taking views from experts and decision makers, factors or dimensions are identified which are important for evaluating a firm's location. These factors vary from firm to firm. For instance, factors influencing a retail firm might be totally different than factors influencing a bank's location. Thus, views and opinions regarding dimensions influencing a firm's location are taken from experts, making it the most important aspect of factor rating method. Step 2 in this method is, after identifying suitable factors pertaining to a particular firm, the consumers of those firms are asked to rate the importance of those factors. Each factor is being rated on a particular scale, indicating its importance to the consumer. For instance, a bank consumer might be asked to rate the importance of easy accessibility and convenient hours for availing services of a particular bank. Similarly, other factors are also rated. The importance of these factors is generally rated on a scale of 0 to 1. Higher the score, more important is the factor. Importantly, it should be noted that identification of factors, which was done in step 1, involves opinion of experts for that particular firm for which factors need to be identified. Whereas in step 2, importance of these factors is judged by taking opinions of individuals who are users of products of the firm under consideration. Step 3. In this step, consumers are asked to rate the importance of identified factors with respect to alternative locations. For instance, an individual might be asked to rate the importance of a particular factor, such as easy accessibility, regarding a bank if it is located at location A or location B. Most likely, for different locations, each factor would be scored differently. The bank under consideration might not be easily accessible if it is located at A, so it would be scored lowly as compared to B. Thus, regarding this factor, location B is preferable. The location alternatives are scored generally on a scale of 0 to 100, where higher the score, higher importance is given to particular location with regard to that factor. Step 4 in this method is, the importance is assigned to each factor in step 2 is multiplied by the importance given to location alternatives with respect to that factor. Then sum of these factors is calculated. Higher score for a particular location would suggest selection of that location for establishment of that firm. Factor rating method methodology is illustrated in the following example. The company wants to make decision that whether to locate an apparel store in a shopping mall or in a traditional shopping street. The following table indicates the selected factors for evaluating location of such store. Some of these factors are closeness with other retail stores, volume of customers, rental costs, availability of space, operating costs other than rental costs, easy accessibility, sufficient availability of parking space, and location of the store depends on availability of other entertainment facilities like food outlets, etc. The table shows identified important factors and scores assigned to each factor by an individual. For instance, importance assigned on a scale of 0 to 1 for each factor is shown in the table. Closeness with other retail stores is given an importance of 0.7, and sufficient availability of parking space is given the maximum importance with a score of 0.8, whereas operating costs other than rental cost is given as least importance with a score of 0.3. After assigning such weights to each factor from 0 to 1, consumers are then asked to rate on a scale of 0 to 100 the importance of two alternative locations under study, namely shopping mall and traditional shopping street. The responses have been shown in the following table. For instance, the factor closeness with other retail stores is given a score of 70 in case of traditional shopping street, whereas same factor is given a score of 40 if it is available in a shopping mall. Similarly, all other factors have been scored on a scale of 0 to 100 with regard to the two alternative locations. To analyze the location alternative, multiply the weights assigned in the above table and scores given in different locations. The results have been shown in the following table. For instance, the scores for closeness with other retail stores has been calculated by multiplying the weight assigned, that was 0.7, into the importance given, that is 70, which comes out to be 49. For the same factor, the score was 28. For the second factor, volume of customers, similar score was calculated by multiplying the weight 0.4 with the importance 55, which gives out to be 22. For the same factor, volume of customers score was obtained to be 26. Similar scores were calculated for all other factors for both the alternative locations. In the end, the total sum of all the scores for each alternative location was calculated. The total score for traditional shopping street came out to be 291, and for shopping mall it was 273.75. These results clearly indicates that traditional shopping street would be a better location alternative for apparel store under study. Next method is the center of gravity method. Center of gravity method is predominantly used to evaluate location of distribution centers such as warehouses. This method assumes that manufacturing facility or service center is providing similar or only one kind of product or service. Also, inbound and outbound transportation costs are assumed to be equal. For instance, Best Price is a famous warehouse chain for Bharti group of companies. It does not locate itself close to customer of retail products, but at the convergence of its primary market of retailers. It is important to note that customers of such warehouse are similar in nature as they retail similar kind of products. An illustration of Best Price has been discussed as under. Best Price warehouse stores FMCG products and also electronic goods. Primarily, it is a supplier to various retailers of different cities of such products. The warehouse wanted to evaluate a location for its new store catering to retailers of three major cities A, B, and C. City A is the capital city and has highest per capita income with largest size of population among selected three cities. City B and City C are similar on per capita and population characteristics. Distance between city A and B is 50 kilometers, between A and C is 60 kilometers, and distance between B and C is 40 kilometers. Coordinates of each city were calculated and demand was estimated. It is important to note that products warehouse is a supplier or distributor of variety of products, but they are similar in nature and supplier to similar kind of retailers. Then coordinates of new location were found by using coordinates of existing locations and demands of each center. By using this method of coordinates, relevant location for new store were found, which was found to be closest to city A. Thus, this method was found to be quite relevant for finding location of distributors supplying similar nature of products. Lastly, after finding coordinates of new location, other information such as cost of transporting and demand should also be considered to finalize the location alternative. Following steps are used in center of gravity method for evaluating location alternatives. Step 1. Locate on a coordinate system for existing locations. Step 2. Calculate volumes being shipped or demand of each location. Step 3. Use the following formula to find coordinates for new location. And the formula for x coordinate is summation of multiplication of demand into volume divided by summation of volume. Similarly, formula for y coordinate is summation of diy into vi divided by summation of vi, where dix is the x coordinate of ith location, diy is the y coordinate of the ith location, and vi is volume of goods moved to or from the ith location. The following table indicates the x and y coordinates of three locations: plant A, plant B, and plant C. Quantity being shipped from these three locations is also given. Quantity to be shipped from plant A is 6,000. Quantity to be shipped from plant B and plant C is 8,200 and 7,000 units respectively. For this data, a new location has to be estimated. X coordinate of the new location has been estimated to be 171.9 by using the above discussed formula. Y coordinate of new location has been calculated to be 262.73 by using the above discussed formula. These two coordinates of the new location along with the coordinates of three given locations is plotted on a graph where x coordinate and y coordinate values are used to plot the locations of different plants. The graph indicates the locations of plant A, plant B, as well as the location of the new plant indicated by the centroid point.
The last quantitative model that has been discussed in this chapter is transportation model. The transportation model involves determination of minimum total cost for distributing a particular type of product manufactured at multiple factories or sources to multiple destinations or demand centers. For instance, a state having multiple thermal power plants might source coal used as raw material for producing electricity from multiple destinations. Now it becomes important for the state to formulate a model which can determine amount of coal to be sourced from which source in such a manner that total transportation cost is minimum. Thus, a transportation model helps in determining, firstly, allocation of units from multiple supply centers to various demand centers. It could be possible that a supply center is used to supply raw material to more than one demand center. Also, it is not necessary that a demand center obtains all the raw material from only one source, as each supplier has different capacity and each demand center would have different demand. Thus, the model helps in finding out number of units each supply center would provide to each demand center to fulfill its total demand. Secondly, total transportation cost should be minimum, as each supply center can supply varying amount of product to different demand centers. Thus, there can be n number of ways in which material can be sourced and can be supplied. This model, by taking into consideration transportation cost of each unit to be supplied from every supply center to every demand center and number of units allocated for transportation, from a particular supply center to a particular demand center calculates most optimal transportation cost.
The next method that was discussed is the transportation model, but this model can only be applied if following assumptions are fulfilled. The first assumption is that there should be known and finite number of supply centers. Second, there should be known and finite number of demand centers. Third, all the supply center manufacturers or provide identical product. Fourth, the demand of each destination and capacity of each resource center should be known. Lastly, the unit costs of transportation from each origin to each destination should be known.
Application of transportation model in location decisions. The transportation model can be used to evaluate feasibility of various locating alternatives by comparing each alternative in terms of their transportation cost. For instance, in the example discussed, warehouse A has a demand of 80 units, which can be fulfilled by any of the three supply centers. So model would allocate 80 units to be supplied from each supply center and then see its impact on total transportation cost. Finally, that model would be selected which would minimize total transportation cost.
These assumptions have been illustrated in the following figure, where three supply centers or factories are S1, S2 and S3. Three demand centers are D1, D2 and D3. Cost of transportation from S1 to D1 is shown by C11 and other costs are also shown. Demand of one center can be fulfilled by any of the three supply centers. Transportation model would find which supply center should supply how many units to which demand center so that total transportation cost is minimum. To understand number of scenarios in which demand of each demand center can be fulfilled from various centers, this figure is quite illustrative. In the figure, we have illustrated by taking three supply centers and three demand centers. Determination of how many units to be allocated from each supply center to different demand centers becomes quite difficult if done manually. Usage of computer software is recommended when number of supply and demand center increases. This slide illustrates an example of transportation model. The data in the following table gives information about transportation cost of a product being transported from any of the given three supply centers to four demand centers. The demand of each demand center and capacity of each supply center is also given. For example, demand center A is 80, demand for B is 90, and for C and D it is 120 and 160 units. Supply of supply center 1 is 100 units, supply center 2 is 200 units, and supply from supply center 3 is 150 units. By using transportation model, number of units being transported from which supply center to which destination needs to be determined in such a way that total transportation costs comes out to be minimum. This table shows three supply centers 1, 2 and 3, four demand centers A, B, C and D, transportation cost from each factory to each warehouse. For instance, the first cost cell indicates that Rs 4 is required to transport one unit from factory 1 to warehouse A. Also, supply and demands for each supply center and each demand centers are indicated. Lastly, it is important to note that total demand of 4 warehouses and total supply of 3 centers should be equal. In this case, it is 450 units. The solution to discussed problem is shown in the following table by using computer software. The methodology of obtaining optimal transportation cost is tedious and is not discussed in this chapter. The total transportation cost comes out to be rupees 2300. Thus, 450 units can be supplied from 3 factories to 4 warehouses by incurring a transportation cost of rupees 2300.
To conclude, this chapter discusses quantitative methods of deciding an appropriate location for a firm when it faces multiple location alternatives. Factor rating method is one of the most widely used methods in location decision making strategy. It involves identifying most important factors used in evaluating a location and also the importance given to various location alternatives based on these factors. Cost volume profit analysis method is used to calculate costs and profits involved in producing similar product at various locations. The location which provides maximum profit at minimum cost is considered to be most suitable. Center of gravity method is an appropriate method to find location of firms involved in distribution of similar kind of products, such as supply of products from a warehouse to similar retailers. Lastly, transportation method uses transportation cost per unit from various supply centers to multiple demand centers to calculate transportation cost of various locations. Thank you.